Welcome to Talk Tickers.
Glad to be here for this one.
If you are tuning in right now, let us get the ground rules straight right out of the gate.
Yeah, we have to set the stage.
You are not here for tech support. And you are certainly not here for the hype cycle or to find out which dog coin is going to the moon next week.
Definitely not.
You are here because you manage capital. You are here because you need to understand the plumbing that moves that capital.
The underlying rails.
Exactly. We treat protocol upgrades like earnings calls, and we look at architectural shifts like market mechanism breakdowns. We are looking for the signal in the noise.
That is exactly right. We aren't looking at the price action of the day. We are dissecting the infrastructure that will dictate capital flow for the next decade.
We look at the pipes, not the water.
Right. And today's deep dive is focusing on a concept that, honestly, on the surface, it sounds incredibly dry.
It sounds like back-end developer jargon.
It really does. It sounds like something you would just skip over in a pitch deck. We are talking about account abstraction,
Yes.
or AA.
But here is the thesis up front for you, the listener. To a portfolio manager or a serious investor, this is the difference between a market cap ceiling of $1 trillion for the entire asset class and a market cap of 10 or 20 trillion.
It is the difference between a prototype and a finished product. I mean, if we look at the current state of crypto adoption, we have hit a hard bottleneck.
The wallet problem.
The wallet problem, exactly. We have these incredibly sophisticated DeFi protocols out there. Automated market makers, lending pools, complex derivatives that frankly rival anything on Wall Street.
But the access point for the user is primitive.
It is primitive. It is effectively the digital equivalent of stuffing cash under a mattress and just hoping the house does not burn down.
I would argue it is actually worse than that. Let us look at the status quo. The industry standard right now is the externally owned account, the EOA.
Right, your standard setup.
This is your MetaMask, your ledger. It relies on a seed phrase. If you lose that piece of paper, if you lose that string of 12 or 24 words, you are bankrupt.
Yeah.
There is no appeal process. There is no forgot password button. There is no customer service line to call.
No.
And from a usability standpoint, if you want to move, say, $1 of USDC, you need to hold a volatile asset like Ethereum just to pay the toll.
It creates a friction-heavy environment that is simply uninvestable for the mass market. I mean, imagine if you walked into a Starbucks to buy a latte with your Visa card. You swipe the card, but the cashier stops you and says, I'm sorry, you cannot pay the transaction fee with dollars. You have to pay the transaction fee in gold dust.
Right.
And you have to carry that gold dust in a separate pouch from your wallet. And if you run out of gold dust, your Visa card is frozen.
Nobody would use that system.
Nobody. But that is the current user experience in Ethereum.
And that is exactly why we are still in the early adopter phase. It keeps the asset class niche. So account abstraction is the infrastructure upgrade that moves blockchain accounts from being dumb key pairs where the key is the account to smart programmable bank vaults.
That is the perfect analogy. We are moving from a bearer instrument, like a physical gold coin where possession literally equals ownership, to a programmable account structure, one where ownership is defined by rules, logic, and code.
So the scope of today's deep dive is the technical shift from these externally owned accounts to contract accounts. We're going to break down the mechanics of ERC 43307, which is standard everyone is rallying around right now.
We really need to dig into the new economic actors this creates, specifically bundlers and paymasters.
Because there is an investment thesis in that layer alone.
A massive one.
And we need to look at the future, specifically native AA and the upcoming Petra upgrade with EIP 7702.
We also need to talk about the agent economy, because everyone is talking about AI right now, but very few people are talking about how AI agents will actually transact.
Account abstraction is the banking rail for artificial intelligence.
Exactly. It is the missing piece.
We will get to the robots later. First, we need to unpack the plumbing. Standard disclaimer applies here for you listening. We are discussing market mechanics and technology stacks. We are not recommending specific wallets, tokens, or protocols.
We are strictly analyzing the infrastructure.
Let us start with the core concept. What do we actually mean by abstraction? What are we abstracting away?
We are abstracting the authentication logic. The core concept is decoupling.
Decoupling the asset from the key.
Right. We are separating the object that holds the assets, the account, from the object that authorizes moving them, the signer or the key.
Because in the status quo, the EOA, those two things are fused together.
They are completely fused. The private key is the account. The logic is hard-coded by the Ethereum protocol using ECBSA signatures. That is the elliptic curve digital signature algorithm.
Meaning the protocol dictates the rules. You cannot change them.
Correct. The protocol basically says if you have the private key, you own the funds. That is the one and only rule. You cannot program it. You cannot say only allow a transfer if the price of ETH is above $3,000.
You cannot add conditions.
No conditions. You cannot say require 2 signatures if the amount is over $500. The account is totally dumb. It just listens for the key.
So if I want to change my security setup, say I suspect my key is compromised, or I just want to rotate it for basic corporate hygiene, I would create a whole new account and sweep the funds.
Exactly. You have to move all the assets. It is like having to build a brand new house every time you want to change the lock on the front door.
Which is wildly inefficient.
It is terrible.
Yeah.
With account abstraction, the wallet becomes a smart contract. It is code deployed on the blockchain. This means that the logic of who can spend this money is defined by software, not by the protocol's hardwired cryptography.
And the implication of that is flexibility.
Massive flexibility. You can change the signer. You can rotate your keys without moving the assets. You can have multiple signers. You can use Face ID or the secure enclave on your iPhone as a signer.
Because the blockchain doesn't care how you sign, as long as the smart contract wallet accepts the signature.
Exactly. The contract makes the rules now.
Okay, so that is the concept. But how does it actually work on Ethereum? Because Ethereum wasn't built for this originally.
No, it wasn't.
And they didn't want to do a hard fork to make this happen, which seems like a massive constraint from a developer perspective.
It was a massive constraint. And this is where we get into the weeds of ERC 4337. It is a brilliant piece of engineering because it implements account abstraction without changing the consensus layer of Ethereum.
It creates a secondary transaction layer.
Right. It starts with a shift in the fundamental unit of action. We stop using transactions, capital T, and start using user operations or user ops.
Let's drill down on this. A user op. Say I am a user and I want to send 10 USDC to a vendor. I am not sending a transaction to the network.
Not directly. In the old model, you sign a transaction and broadcast it to the network. Miners or validators pick it up. In the ERC 4337 model, you send a pseudo-transaction object.
A pseudo-transaction.
Yes. This user op contains the intent, like I want to send 10 USDC, and it contains the signature and some other data fields.
Yeah.
But here is the critical difference. This user op does not go to the main Ethereum memory pool.
The mempool being the waiting room where pending transactions sit before they are written to a block.
Exactly. But user ops cannot go there because the Ethereum protocol doesn't recognize them yet. They are alien object to the base layer. So they go to a separate waiting area, the alt mempool.
The alt mempool. This sounds like we are fragmenting the liquidity of the network's attention.
In a way, we are creating a specialized lane. The user ops sit in this alt mempool waiting to be picked up. And this is where we introduce a new economic actor, which I think is fascinating for anyone looking at infrastructure plays.
Oh,
bundler.
The bundler. This sounds like a new form of miner or validator. Is this a rent-seeking middleman?
It really depends on your definition of rent-seeking. I would call them specialized service providers. Or maybe high-frequency logistics operators.
Okay, what do they actually do?
Bundlers are actors running nodes that monitor this alt mempool. Their job is to grab a bunch of these user ops, bundle them together into a single standard Ethereum transaction, and submit that transaction to the chain.
So the bundler is the bridge. They take the new format, wrap it in the old format so the blockchain can understand it, and push it through.
Exactly. But let us look at the P&L of a bundler, because this is where the economics get tricky for operators. The bundler pays the gas fees up front in ETH. They take the risk. They pay the network to process the bundle.
Hold on. Why would they do that? Why would any rational economic actor pay gas fees for a stranger's transaction?
Because they are arbitrageurs. They get paid back. The user op contains logic that says, if you process this, my smart wallet will refund you.
Ah, so there was a spread.
Usually, yes. The user might agree to pay a certain maximum amount, and if the bundler can execute it for slightly less gas or organize the bundle incredibly efficiently, they keep the difference.
So they're taking on inventory risk, they're buying block space with ETH and reselling it to users who are paying via their smart contracts.
Precisely. They are taking on the volatility risk of the gas market. If a bundler picks up a user op, calculates that it will cost $5 to execute. But by the time they submit the bundle, the gas price spikes to $7. The bundler eats that loss.
That sounds like a tough business model.
It is a low-margin, high-volume game. It will likely end up dominated by sophisticated actors who can optimize gas usage down to the single byte. It is very similar to how high-frequency trading firms dominate market making in traditional finance.
You won't see mom-and-pop bundlers.
Definitely not. Which creates a centralization factor, and we should discuss that later.
But there is another risk here. How does the bundler know the wallet actually has the money? If I send a malicious user op that says, I will pay you back, but my smart wallet is empty, the bundler pays the gas to the network, tries to collect from me, and fails. They lose money.
That is the denial of service vector, the DOS vector. To solve this, the architecture uses a global singleton contract called the entry point.
The traffic cop.
Think of the entry point as the central clearinghouse for AA. There is one entry point contract on the network. The bundler submits the batch to the entry point, not directly to the individual wallets.
Okay, so what does the entry point do?
The entry point runs a simulation. It talks to each smart wallet and asks two questions. Is the signature valid? And do you have the funds to pay the bundler?
So it verifies creditworthiness before execution.
Exactly. It validates everything. If the validation fails, say the signature is wrong or the balance is too low, the transaction is rejected immediately. The bundler doesn't pay for the heavy execution gas, only a tiny amount for the initial check. It minimizes the risk.
So the entry point protects the bundler's capital.
It protects the bundler, and it protects the network from spam. It ensures that the fee market remains functional even though we have abstracted the payment mechanism.
Speaking of the payment mechanism, this leads us to the paymaster. To me, this is the most disruptive part of the stack for commercial applications. If bundlers are the logistics trucks, paymasters are the credit card companies.
That is a very fair comparison. A paymaster is a smart contract that agrees to pay the gas fees for a user. This is how we finally achieve the gasless experience.
We hear gasless a lot in marketing decks, but nothing is truly gasless on Ethereum. Block space costs money.
Correct. Gasless is a misnomer. It should be called gas subsidized or gas abstracted. Someone is always paying. The paymaster just shifts who is paying. There are two main types of paymasters that investors need to understand because they represent two fundamentally different business models.
Break us down.
First, you have the verifying paymaster. This uses off-chain logic to decide sponsorship. This is a customer acquisition cost play, a CAC play.
Give me an example.
Imagine a company like Nike issuing a digital collectible. They want mass adoption. They don't want their users to have to buy ETH. So Nike sets up a paymaster contract.
And the logic is, if this user is minting our shoe, we pay the bill.
Exactly. The user initiates the transaction. The paymaster checks the intent. Oh, you are interacting with the Nike contract. Approved. The paymaster puts up the ETH for the gas. The user pays 0. To the user, it feels exactly like Web 2. They click a button, and it happens. Nike treats the gas cost as a marketing expense, just like paying for server space for a website.
That changes the onboarding funnel entirely. You don't need to send a user to an exchange, have them pass KYC, link a bank account, buy ETH, wait 3 days for settlement, transfer to a wallet, and then finally buy the shoe.
No, they just buy the shoe.
It collapses the funnel from 10 steps to 1. The conversion rate implications are astronomical for retail brands.
They really are, and that brings us to the second type.
Let us hear it.
The second type is the deposit or ERC20 paymaster. This basically creates a foreign exchange market for gas. This allows users to pay gas in USDC, DAI, or potentially any liquid token.
So I have USDC in my wallet. I want to send it. I do not have ETH.
In the old world, you are stuck. You cannot move. In the AA world, you sign a user op that says, I am willing to pay 5 USDC for this transaction. The paymaster sees this. It accepts your 5 USDC. In the background, practically instantaneously, it pays the bundler in ETH.
So the paymaster acts as the FX desk. They take the stablecoin, they pay the network currency, and they pocket a small spread for the convenience.
Precisely. The user never needs to know what WEI is. They never need to worry about ETH price volatility affecting their transaction costs. It creates a predictable, fiat-denominated experience on top of a volatile settlement layer.
And for the paymaster operator, it is a yield-generating activity. They're essentially a liquidity provider for gas.
That is exactly what they are.
There's one more piece of the architecture I want to touch on before we move to the history. Aggregators.
Aggregators are optimization tools. In cryptography, verifying one signature takes X amount of compute. Verifying 10 signatures usually takes 10x. But with certain cryptographic schemes, like BLS signatures, you can compress those 10 signatures into one single mathematical object.
So you verify the group once and it proves all 10 are valid.
Exactly. It saves space on-chain. Less space means less gas. This is critical for scaling rollups, where data availability costs are the main bottleneck. Aggregators allow us to pack way more throughput into the exact same block space.
Okay, let us zoom out for a second. We are talking about ERC 4337 like it is the brand new standard, but this concept has actually been around for a long time. Vitalik Buterin has been talking about this since before Ethereum even launched. Why did it take a decade to get here?
Vitalik proposed this as early as 2015. The original vision for Ethereum was actually much more flexible. The problem was complexity and timing. When the network launched, they needed something robust and simple. EOA's simple public and private key pairs are very robust. They are hard to screw up at the protocol level.
It was a minimum viable product decision.
It was, but it created significant technical debt. Because the protocol dictates everything about an account, the goal has always been to eventually allow developers to define account verification logic. But Ethereum now has hundreds of billions of dollars secured by the current EOA model. You cannot just turn that off.
It is like trying to change the engine of a 747 while it is in mid-flight.
With 300 passengers on board, exactly.
And this leads to a divergence in how AA is being implemented today. We have the layer 2 approach versus the Ethereum layer 1 approach. This is crucial for investors analyzing the L2 landscape right now.
It is a fundamental differentiator. If you look at newer layer 2 networks like Starknet or ZK Sync, they implemented native AA.
Meaning it is baked in.
Baked in at the protocol level. On Starknet, there are no EOAs. They do not exist. Every single account is a smart contract from day one. They do not need the alt mempool. The sequencer, the entity that orders transactions on the L2 handles user ops natively.
That seems much more efficient.
It is cleaner. It offers better UX out of the box because the infrastructure assumes programmability from the ground up. Starknet wallets can integrate rigid hardware signing logic directly into the account structure without needing a complex overlay.
But Ethereum L1 had to take the overlay route.
Right. ERC 4337 is an overlay. It was built because the core developers were busy with the shift to proof of stake. That was the existential priority. They could not prioritize a fundamental rewrite of the account system simultaneously. So the community built ERC 4337 to work on top of the existing chain without requiring a hard fork.
The trade-off being cost and complexity.
Yes. There is a gas overhead. A simple transfer using ERC 4337 uses significantly more gas than a standard EOA transfer, sometimes 100,000 gas units more per bundle just for the processing overhead. On a cheap L2, that is negligible. On Ethereum mainnet during high congestion, that is expensive.
But there is a convergence coming. We keep hearing about the Petra upgrade in EIP 7702. This seems to be the bridge between the two worlds.
EIP 7702 is fascinating. It is the next evolution. It addresses the migration problem. We have millions of users with EOAs right now. Asking them to create a new wallet and transfer their assets is a high-friction event. Most won't do it.
So what does 7702 do?
It effectively allows a standard EOA, your old MetaMask wallet, to temporarily turn into a smart contract wallet for the duration of a single transaction.
Wait, explain that. It transforms, like a temporary upgrade.
In a way, it allows an EOA to sign a transaction that says, for this specific action, point my account code to this smart contract logic. It allows users to rent the features of account abstraction, like batching or gas sponsorship, without having to migrate their assets to a new smart contract address permanently.
That is huge for legacy users. You do not have to leave your address to get the new feature.
Exactly. It breaks the deadlock. It allows existing users to access next-gen features immediately. It is a very pragmatic solution to bridge the gap between the legacy EOA world and the smart account future.
Let us pivot to the deep dive on investor implications. Why does this matter for the portfolio? Let us start with risk mitigation and security. Custody is the absolute nightmare of crypto.
The grandma test has always been the failure point. If you cannot explain to your grandmother how to secure her savings without losing a scrap of paper, the tech is not ready for prime time.
Right.
The current model relies on key management. The user protects a secret. AA shifts this to account management.
Explain the difference in practice.
In account management, you define rules. The biggest one is social recovery. No more seed phrases hidden in a safe. You define guardians. These can be other wallets you own, they can be trusted friends or family, or they can be institutional hardware security modules.
If I lose my signer signs, I do not lose the account.
You do not lose the account. You ping your guardians. You say, I lost my key. If, say, 3 out of your 5 guardians agree, they can send a transaction to your smart account that says, rotate the key to this new one.
The assets never move. You just change the lock on the door.
Exactly. And this extends to corporate governance. This is huge for institutions. We talk about multi-sig like Gnosis safe, but AA makes multi-sig programmable logic inherent to the account itself.
Give me a corporate treasury example.
You can write a rule that says any transfer under $1,000 needs 1 signature from a junior trader. Any transfer over $10,000 requires the CFO's signature. Any transfer over $100,000 requires the board's approval and a 24-hour time lock.
That sounds like basic financial controls that exist in every Web 2 banking interface finally coming to Web 3.
It is. It allows crypto to seamlessly integrate with existing corporate governance structures. And there is a future-proofing element here too. Quantum resistance.
I wanted to touch on that.
Standard Ethereum accounts use specific cryptography ECDSA that could theoretically be broken by a sufficiently powerful quantum computer in the future. Because an EOA is hard-coded, if that cryptography breaks, the account is dead.
You would have to move the funds to a new chain or a new address type before the computer cracks it.
Right, it would be a mad dash. But with the smart account, the validation logic is code. We can upgrade the code. We can swap out the signature algorithm for a quantum resistance scheme like Lamport signatures or Stark's without moving the funds. It makes the account adaptable to future threats.
That is an insurance policy embedded in the architecture. Now, let us talk UX, the growth catalyst. We have seen concepts like session keys emerging, particularly in the gaming sector.
Session keys are absolutely critical for the high-frequency sectors. Imagine playing a fully on-chain game. If you have to sign a transaction pop-up for every single move you make, every time you pick up an item or swing a sword, the game is unplayable.
It totally breaks the flow. It is terrible UX.
Session keys solve this. You sign one transaction at the start. That transaction creates a temporary key, a session key. You grant that key permission to sign transactions on your behalf, but with strict predefined limits.
Like what?
Like this key works for exactly 1 hour. It can only interact with the specific game contract. It cannot spend more than 5 USDC from my main balance.
So the game plays smoothly in the background. The back end handles the signing using the session key. The user just plays the game.
Invisible. The blockchain interaction becomes entirely invisible. This is how you get millions of daily active users who do not even know they are using crypto rails. They just know they actually own their in-game items.
Yeah, we touched on gas abstraction earlier, but the implications for batching are also significant for DeFi traders.
Huge. Right now, if you want to trade on a DX like Uniswap, you usually have to do 2 transactions. First, you approve the token, giving the protocol permission to spend it. Then you swap the token.
2 clicks, 2 gas fees, 2 points of friction.
And if the first one works but the second one fails because gas spiked, you have wasted money and accomplished nothing.
With AA, you batch that.
You batch it. 1 click. The smart contract handles the approve and swap atomically. If one fails, they both fail. It is cleaner, faster, and cheaper. It aligns the blockchain interaction with the user's intent. The user has one intent: swap. The blockchain should have 1 transaction.
Now, here's where I want to really expand, because this connects to the biggest trend in technology today. The macro thesis. The AI agent economy.
This is the trillion-dollar idea.
We are seeing a massive proliferation of autonomous agents. They are scraping the web, they are writing code, they are analyzing markets. But they have a constraint in the physical world.
They have a massive constraint. They cannot open bank accounts. An AI agent does not have a passport. It does not have a utility bill. It cannot pass KYC. It is functionally unbanked in the traditional financial system.
Right. JP Morgan is not going to open a checking account for a Python script.
Exactly. But the agent needs resources to function. It needs compute power. It needs data. It needs to pay for API access.
And currently, a human has to hold the credit card. The human is the bottleneck in the agent's operation.
The human is the limiting factor. The AA solution provides a blockchain-based foundation for these agents. It gives them a bank vault that software can natively understand.
We call this agent sovereignty.
Agent sovereignty. The agent generates its own keys. It establishes a decentralized identity, or DD. It does not need a government ID. It needs a cryptographic key pair. With account abstraction, the agent becomes a first-class economic citizen. It can hold USDC, it can pay for services on its own.
So an agent can pay another agent directly.
Trustless settlement. Imagine Agent A needs to process a massive data set. Agent B sells compute power. Agent A pays Agent B in micropayments using a stablecoin via an AA wallet.
Screaming payments by the millisecond.
Yes. No human intermediary, no Visa network taking 3%. This is the machine-to-machine economy.
But wait, how do we trust these agents? If an agent rips me off, I cannot sue it. I cannot take a robot to small claims court.
This is where reputation capital comes in. Because the agent's history is on-chain and its identity is tied to its smart account, it builds a proof of competence over time.
A track record.
You can verify it. Has this agent successfully completed tasks before? Has it paid its bills on time? The AA infrastructure allows agents to interact with complex protocols autonomously, building reputation with every block.
So the agent builds a credit score, essentially.
A verifiable, immutable on-chain credit score. And this leads to economic decoupling. Agents can operate in a completely closed-loop economy. An agent could optimize energy grids, get paid in crypto, use that crypto to buy more server space, and upgrade its own code.
It creates a self-sustaining economic loop that human financial rails simply cannot support due to compliance overhead.
That is a staggering market opportunity. We are talking about the GDP of the machine world.
But we have to look at the other side of the trade here. What are the risks and downsides? Because if it is software, it can break.
The biggest risk is smart contract risk. We are moving from hardware-level security, simple private keys, to software-level security. The wallet is now code, and code has bugs. If the wallet contract has a vulnerability, funds can be drained. This introduces an entirely new attack vector that simply did not exist with simple EOAs.
If the lock is digital, the lock can be hacked. With an EOA, you cannot hack the cryptography. You can only steal the key. With a smart account, you might not need the key if you can trick the contract logic.
Exactly. This makes audits absolutely critical. It makes formal verification, mathematically proving the code does what it says it does, critical.
What about the infrastructure layer?
Then you have centralization vectors. We talked about bundlers earlier. If there are only 3 major bundlers controlling the alt-mem pool, they can censor transactions. They can decide which user ops get on-chain and which get ignored.
So we recreate the exact censorship problems we try to solve at the base layer. If the bundlers are all in one jurisdiction, and that jurisdiction says sanction this address, the bundlers comply.
It is a very real risk. The market desperately needs a diverse, decentralized network of bundlers.
And the paymasters.
Relayer reliance. If you rely on a paymaster to sponsor your gas and that paymaster service goes offline or runs out of ETH, your transaction might fail. You won't lose your funds, but you lose utility. You are reintroducing a dependency on a centralized service provider.
It is a trade-off between convenience and sovereign robustness.
Always. There is no free lunch in system design. You're trading the simplicity and rigidity of the EOA for the extreme flexibility and complexity of the smart account.
Okay, we have covered the mechanics, the history, the macro thesis, and the risks. Now, we arrive at the most important part of the deep dive for our listeners who are actually deploying capital, the one question.
The one question.
If you are an investor looking at a project, a protocol, or a wallet infrastructure play leveraging account abstraction, what is the single most important question you need to ask the team during due diligence?
The question is, who controls the upgrade path of the smart account?
Expand on that. Why is that the defining question?
Because in a programmable wallet, the code can be changed. That is the main feature, but it is also the ultimate bug. Most of these systems use what we call a proxy pattern. The address you hold funds in is just a shell that points to a logic contract elsewhere.
Okay.
If the developer retains a backdoor or an admin key that allows them to upgrade that logic contract without your signature, they effectively have custody of your assets.
Explain the nightmare scenario for an investor.
They could upgrade the wallet to a new version that says, simply send all user funds to the developer's address. It is a rug pull mechanism disguised as a feature update. If they have unilateral upgrade power, it is not your wallet. It is their wallet that you are merely using.
But if the wallet is totally immutable and cannot be upgraded at all, you lose the ability to patch security vulnerabilities or add new features like quantum resistance.
Correct. So you need a balance. You need to deeply understand the governance of the code. Is there a time lock? For example, upgrades take 7 days to activate, giving you time to withdraw your funds if you disagree.
Or is it a DAO vote?
Right. Or is it social recovery controlled strictly and only by the user? This balance defines the true ownership model of the assets.
Who controls the upgrade path? That determines if you own the asset or if you are just renting the interface. That is the real alpha here.
Precisely. It is the most important diligence question in the space right now.
Let us wrap this up with the key takeaways for you, the listener. What are the 3 things you need to lock in from this deep dive?
Number 1, this is a paradigm shift. We are moving from key management, where the user protects the secret, to account management, where the user defines the rules. This is exactly how we onboard the next billion users who will never, ever write down a seed phrase.
Takeaway number 2.
It is an infrastructure play. The rise of bundlers and paymasters creates a brand new B2B infrastructure layer in crypto. It enables gasless experiences that mimic Web 2, but with Web 3 settlement. This is a massive investable sector in itself. Watch the companies building the bundler networks and the paymaster APIs.
And number 3.
Agent enablement. AA is the financial rail for autonomous AI. It gives software the ability to bank and transact without human sponsorship. This unlocks the machine economy. If you are bullish on AI agents, you have to be bullish on account abstraction as their settlement layer.
Standard disclaimer time. Nothing you heard today is financial advice. We are analyzing mechanics, not markets. Do your own diligence, especially on smart contract audits.
Code is law until it breaks. Always check the audits.
And before we go, here is a final provocative thought for you to chew on. We talked about EIP 7702 temporarily upgrading legacy wallets. But what happens if 5 years from now, the Ethereum base layer decides to deprecate EOAs entirely? What if the network forces a migration, making smart accounts mandatory to participate in consensus? The friction of that event could be the biggest liquidity reshuffle in the history of the asset class. Think about who wins that migration.
That would be wild.
That is it for this deep dive on account abstraction. We will see you on the next one. Talk tickers.